Next important activity that is to be done by the network layer, or the next important functionality of network layer called internetworking. That is how different networks will connect each other and how they will work together irrespective of the heterogeneity that exists among them. So until now we have implicitly assumed that there is a single homogeneous network. So that was the assumption we taken so far, and we don't know what we will do, means what are all the difficulties that will occur in a real network which is not homogeneous in nature, right? With each machine using the same protocol in each layer, but that is not the case in reality. So in reality many different networks exist. Of course we know the different types of network based on their geographical size, right? The personal area network, the local area network, the metropolitan area network, wide area network. So like that, with different standards, of course, like 802.3 the Ethernet standard, the the Ethernet, that is the popular wired local area network. Similarly we have the wireless local area network standard 802.11, the Wi-Fi, the personal area network, Bluetooth 802.15 standard, and of course this WiMAX 802.16, the wireless metropolitan area network, right? So like that many different standards as well as a numerous number of protocols also exist. They are in widespread use across this network in every layer. So let's have a look at the issues that arise when two or more networks are connected to form an internetwork. So this is what is our original internet, like where you can't expect this kind of a homogeneity, rather things are heterogeneous in nature. So how things will be interconnected, so that is what we are looking at. So it would be much simpler to join networks together if everyone uses single networking technology. So then everything is straightforward. If it's running on a single platform, that is fine, but that is not the case, right? Because across the world there will be different network, and everything should be connected to each other. So then only you can achieve connectivity to someone who is sitting remotely. But of course there are dominant kind of networks like Ethernet, but still there are many different networks, protocols, standards, etc. exist. So everyone want to work together. Instead, if you can replace everything with say few protocols, that will be more fine, but that is not the thing, right? So we have to encourage new protocols, standards, everything that is emerging. Maybe a better one may come in the future. So heterogeneity will be there, and we should be ready to deal with it. So what is heterogeneity? The reusing of the existing system, such as running data network on top of the cable. So table is something particularly initially it's meant for voice data. Later we started reusing it for the data traffic also. The telephone network and the power lines adds, of course it will add constraints that cause the features of the network to diverge. So that diversity is something what we call as heterogeneity, and we should be able to deal with it, right? So Bob Metcalfe postulated that the value of a network. So there is something he postulated regarding value of a network. Say with n nodes, a particular network is containing n nodes. It is as per Bob Metcalfe, the value of a network with n nodes is the number of connections, right, that may be made between the nodes. So between n nodes, how many connections are possible? Typically there will be nc2, right? Out of n, how many pairs are possible? Like nc2, that many connections are possible, which is approximately n square. So if there are n nodes in a typical network, there will be n square connections, and this n square is going to define value of the network. So large networks are often more valuable, right? Because as network is large, number of nodes will increase, accordingly n square will increase. So they are of more value as per the postulate, and then small network, because they allow many more connections. So there always will be an incentive to combine smaller networks. So when we combine smaller networks into larger one, definitely we are achieving more connectivity. So that is the incentive, right? So that will add more value to our network and more usefulness. So that is something coming from the postulate made by Bob Metcalfe. So the internet is the prime example of this interconnection. So in general, so the collection of network, in that way we can use the term internet, and also the current interconnected network, that can also be given the name internet. So normally in textbook and all, capital I denotes it as a particular network, and small I, whenever they are using, that mean like just a collection of network in that sense. So both case this terminology is used, internet, right? Okay, just a collection of network, that's also. When you pay an internet service provider, you are getting service from internet service provider by paying, right? So you are supposed to pay them. So what you are getting, so the internet service, so you may be charged depending on the bandwidth of your line. So how much bandwidth they are providing, accordingly you are supposed to charge. So but what you are really paying is for the ability to exchange the packet with any other host that is also connected to the network. So more bandwidth means the network connectivity is increasing, right? So now it started trying to exchange your information some different network even. So right now you are in a particular network. When you started exchanging your information to a different network, definitely difficulty will be there, and that is what is going to add that cost for the internet. So that is what you are paying, right? And since networks often differ in important ways, getting packet from one network to another is not an easy way. We will see the difficulties and how things are handled in a brief way. So we must address the problems of heterogeneity and of course the problems of scale. So when you add more devices, the scalability will come into picture. So how we will handle both heterogeneity and scaling as the resulting network grows very large. Right, so if you are looking at the how the networks are differ from one to another, there are many criteria on which the network will differ. So some of them were listed here. As the first one, say the service offered, right? So what kind of service is being offered? Some networks are providing you the connectionless service like the in IP service, Ethernet, right? But if you are looking at the TCP and all, they are providing connection oriented service. So from network to network, the types of service being offered will vary, and the addressing mechanism, different size for the address. The typical MAC address we have 48 bits, but if you are looking at some other address, maybe IP address 34 bit, and different addressing schemes were there, and we have the concepts like flat as well as hierarchical addressing. Anyway, what we already gone through is flat addressing. Hierarchical addressing is not there in your syllabus, that is why I didn't cover, but if you are interested, you can read the Tanbun textbook. It is nicely explained in it. Okay, so like that, differences were there. Now of course the broadcasting, whether it is present or absent, in a network, if it is sometimes the network will be focusing only on unicasting, they don't want broadcasting. So whether the network actually demanding broadcasting or not. Similarly about multicasting, and the difference, unicasting, broadcasting, multicasting, hope you are already clear about it. So packet size, every network has its own maximum packet size, the maximum transmission unit, something we will see what it is. In a typical Ethernet, you hope you remember, like it is like 1500 byte, but if you go to some other network, the maximum packet size will be different. And another aspect is of course the ordering, whether they communicate your communication in an ordered way or an unordered way. If you order matters, then even though the things are coming unordered, the receiver is supposed to order them. So such difficulties were there. And of course the quality of service, I have a separate set of videos for QoS that I will be sharing you. Okay, of course, some brief idea hope you are already having about QoS. For the real-time service handler. So QoS is something that we are adding additionally, so whether it is present in a given network or absent, and of course in different kinds we can apply QoS. So to what level it is there, so another factor by which the networks are different. Similarly reliability, different levels of loss we can think of. Security, the privacy rules used by one network will be different for other. The encryption tech methodology, rules, everything will vary, right? So parameters, different timeout, the value of timeout set by one network may be different from other. So there is no, as long as there is no universal standardization for all these things, everything should be handled under the term internetworking. So these are all the functionality of network layer. Yeah. So that makes it a somewhat complex layer, including the routing, whether it is routing, congestion control or internet networking. Many things are to be done by the network layer. So those things we will see. Yeah, another one, accounting, whether they are counting by means of the actual time, say round trip time, or the number of packets received or number of bytes received. So on what parameter the things were measured. Okay, so that also. So like that, the many facts we can list on which on network will be different from other. So this is what makes a system heterogeneous, and we should be able to deal with the heterogeneity when we are having a good network design. Dealing with the network differences, these kinds of differences can be papered over with some effort, right? For example, a gateway, right? Now you are hearing about something called a gateway, like a switch or a router. This is an something higher to network layer actually. So gateway joining two different networks. So inside router even so the router is capable of dealing with the two different data link layer, right? You can place it between an ethernet and a token ring. So like that, different networks it can connect. But if you are using say a particular network with IP protocol and another network with IPX or some other network layer protocol, how they can interconnect each other, we can use somewhat more higher layer device like gateway. So that might generate separate packets for each destination in lieu of better network support for multicasting. So gateway, so first of all they are capable of masking the differences among different network, of course. But what is highlighted here is they are capable of handling multicasting. Multicasting, a particular packet addressed to a given address, so that address is actually representing a group of devices, right? So whenever something is communicated with a multicast address, it is to be delivered to each and every individual in the group. So who is going to do it? You can give the role, the task of separating the information or communicating it properly whenever there is multicasting to a device called gateway. So gateway can handle it. In addition to that, gateway is doing many things like different protocol conversion and all. So this is also can be given to gateway. So whenever something is delivered to gateway, say with a multicast address, it will be having some kind of table where the multicast address could be mapped with the different individual devices which are part of the group, multicast group, and how the devices are getting part of the group and how they are removed. All those things is something handled by a popular protocol called the Internet Group Management Protocol, IGMB. This IGMB is Internet Control Message Protocol. IGMB, these are all network layer protocol in addition to the core protocol IP. So in fourth module we will see this IP protocol, its versions, its header format, it's addressing everything in detail. But when we move on to fifth module, I think these things were also, these are all supporting protocols for the network layer. So this IGMB is the one. So ICMB is something I think you are already familiar with, that condition control, source concha message, echo message, those things, right? So IGMB is something that is taking care of the multicast group. So the group creation, management, everything will be done by IGMB, and the hardware support could be provided by the gateway. So a large packet might be broken up, sent in pieces and then joined back together. So this is how they are dealing with the maximum transmission unit. You are sending some information that is of some bigger size, and on the way it reaches a network, and the network is not capable of handling that much bigger size packet. What the network will do, it will simply broken up your message, so that these small pieces are now the underlying network is capable of handling, and at the receiver side it will be reassembled back, right? So again another functionality of the network layer, the fragmentation and reassembly, all those things that it is doing actually for hiding the differences or masking the differences. So receivers might buffer packets and deliver them in order. So this is another thing we discussed, the ordering, right? If the underlying network is not capable of communicating things in an ordered way, you can take the help of a buffer, and you can buffer them, and using some complex sorting technique you can order them at the receiver side, right? So like that, many things we can add. Similarly, what about the QoS management? If one network is having a strong quality of service and the other one is not having QoS at all, instead what it is providing is best effort delivery. So assume two networks, one with a strong QoS and another with a best effort service. So it will be impossible to make bandwidth and delay guarantees, because QoS need bandwidth and delay guarantees, but when it comes to best effort service, it don't want, right? So we are for real time traffic, this will be a struggle. So when we we try to provide bandwidth and delay guarantees end to end, because on the way we will see some of the best effort service as well as QoS service. So in fact, they can likely only be made while the best effort service is operated at a low utilization or hardly used, which is unlikely the goal of most of the internet service provider. Right. So mostly what we need is, if we want things to be done with the help of best effort network, we are happy. But when we add QoS over it, we will be struggling, and that is something you are getting actually in a paid manner only. So if you are ready to pay more, you will be getting QoS, and accordingly things will be working fine. So in that way this will be modeled. So similarly, security handling mechanism, of course they are problematic, but at least encryption and confidentiality and data integrity can be layered on top of the network. So above network layer what we have is something called application layer, and inside application layer we have the presentation layer particularly, which is capable of handling this encryption, confidentiality, integrity, those things, right? So, or in general over network layer we can add one additional layer for security, so that will handle the differences among all those secure protocols and all. So in that way, whatever all the differences we listed out, we can tackle them one by one. Yeah. So with this we will wind up our topic on internet networking. So I mean the introduction to internet networking, and more details like how this internet networking will be handled, that fragmentation concept in detail, and something called the tunneling, and those things we will see in our subsequent videos. Yeah, thanks for watching.